Hi Mr. Pei, welcome to Jaco Pei channel. Are you looking for more information regarding KSSM Physics Paper 3? This will be the right video for you to referring to. Today, I am going to discuss with you one of the examples of guided practical assignment question. That is modification on experiment 3.5, which is a compulsory experiment in Form 5 KSSM Physics syllabus, Chapter 3, Electricity. The title is to determine the electromotive force, E.M.F, and the internal resistance of a dry cell. Basically, there are two types of questions you will be facing to in your paper 3. There is the guided practical assignment, or in BM we call that Tugasan Amali berpandu. This type of question where the procedure and the diagram is provided, so that candidate will be more easier to answer this type of question. And another type of the question will be non-guided practical assignment. In BM we call as Tugasan Amali tidak berpandu, where the procedure and diagram of the experiment is not provided, so that the candidate have to plan their procedure and draw the diagram based on the material and apparatus given at the checklist. If you are interested to know more information regarding paper 3, you may go to watch the video clip, which the link is at the right corner. Okay, basically this is the theory about the experiment 3.5 you have already learned in your chapter 3. Basically, this is the arrangement of the apparatus in this experiment, where the R is representing as the external resistance, E representing as the E.M.F of the dry cell, I representing as the electric current, and the small letter R representing the internal resistance. So firstly, you have to conduct your experiment and get the value of potential difference and the current, and after that you have to plot graph V against I. So the graph will be like this figure. Okay, so this is a decreasing of the slope, and then you need to relate the graph with the formula V equal to negative IR plus E, and then you rearrange the formula, you will get V equal to negative IR plus E, so that the Y representing as V and the S representing as I. So that means that the gradients of the graph will be representing as the internal resistance, while E will be representing as the intercept Y in this graph. So however, in this video clip, I have do some modification in experiment 3.5. So let us see what is the modification. Mr. Pei arrange a question for you all. Hi students, welcome back. Let us read the question together. So this is a checklist for the apparatus and material provided for this question. So basically, we have about 5 minutes per subject to plan and check your apparatus. So firstly, you have to check is it all the apparatus and material needed is provided, and the quantity for each apparatus or material is in correct amount. So if that is correct in quantities and the type of apparatus, you may just tick the checklist, and immediately you have to go to read the question and plan the experiment. So as mentioned that the question we are going to discuss in this video will be the guided practical assignment so that the procedure and the diagram will be given. So let us read the question together. What is the end for this experiment? You are required to carry out an experiment to determine the electromotive force, E.M.F, and the internal resistance of the dry cell. So the apparatus is arranged according to the diagram. So you may see that there is two types of circuit here. So the ammeter is connected in series and the voltmeter will be connecting in parallel. Okay, so the first reading here, the switch is closed and rheostat is adjusted until the ammeter reading I is equal to 0.2 ampere. So that we need to follow the value which is stated in the question. So this is the first manipulated variable you need to follow, okay, when you're measuring the current. So after that, you have to record the reading of voltmeter, and then the experiment you have to repeat it, okay, by adjusting your rheostat, and you will get your second value of current as 0.3 ampere, and you have to recording your voltmeter reading again as your second data, and then repeat it for the I equal to 0.4, 0.5 and 0.6. Okay, so the step number 5, you have to plot graph R against 1 over I. So this is what the modification I have planned in this question. So basically, for the original experiment in your textbook, you will be properly. So plot the graph V against I. So in this experiment, you have to plot the graph R against 1 over I. How we can get the value R here? So R is actually resistance. So according to the Ohm's law, V is equal to IR. So R will be equal to V over I. So that means you have to divide your value V with I, and then you will get the value for R for each reading. And then the second one, you have to do the calculation for 1 over I. So for example, here the first reading will be 0.2. So that means the first reading for 1 over I will be 1 over 0.2. So the detail of the calculation and experiment will be show you all better. So now let us see together how Mr. Pei conducting this experiment. Let us see together the simulation. Hi students, I am Mr. Pei. In this video, I would like to show you how to conducting a compulsory experiment you have did in Form 5 Physics KSSM Chapter 3 Electricity, that is Experiment 3.5, to determine the electromotive force E.M.F and the internal resistance of the battery. Now let's see what is the material needed for the experiment. That is voltmeter, ammeter, rheostat, battery holder, 1 dry cell, switch, and 6 connecting wire. After we checking all the material needed for the experiment, we may start our experiment by arrangement the apparatus according to the diagram given by the question. Now, let us arrange the apparatus according to the diagram given in the question. Okay, basically the arrangement of the apparatus will be almost like this, which is according to a diagram, and we can start our experiment by inserted the dry cell to the battery holder. The battery have to inserted in the first space of the battery holder, which is at the negative terminal of the battery holder. And now we connect the cold clip with the positive terminal of the battery holder, which is the first red node because we have only one drive cell. So we have to connect the first cold-die clip with the red buttons of the positive terminal. And another end have to connect to the metal parts of the switch. Next, connect the cold-die clip to the another buttons of the switch. And another end of the cold-die clip have to connect to the metal parts of the rheostat at here. Make sure that is connect to the metal parts of the rheostat. Now, I would like to show you how to connect the rheostat in the correct way. To understand this connection, you have to understand the basic components of the rheostat. There consists of 3 terminals in the rheostat. The lower left part of the button is terminal A, and the lower right part of the button is called as terminal B, and the third terminal will be at the top left side, and that is the terminal C. And this is the sliding contact, which will be controlling the length of coil wire connection to the circuit. A rheostat is actually a variable resistance, which is no polar. Either terminal can be connected to the either side of the circuit. So that means that the 3 terminals in the rheostat is not considered as any terminal positive or negative. In theoretical, we know that the longer the coil wire, the higher the resistance will be, and the lower the current will be produced in the circuit. Basically, there are 2 ways to connect the rheostat. The first method will be connecting the rheostat with the terminal B and terminal C. So the terminal C will be at the top left side of the button, and another connection will be at the terminal B, which is at the bottom right side. Now, I want to show you how we connecting the rheostat with the method 1. Basically, the rheostat consists of a coil wire. As mentioned that the longer the wire, the higher the resistance will be. And now, you can see that we started our connection with the first connecting with the terminal C at the top left side, and then connect to the bottom right side, which is the terminal B. You can see that the current at this position will flowing from here to here, showing the shorter distance of the coil wire. Therefore, the current will be showing higher value, because in the shorter distance of the coil wire, the resistance will be lower and the current flowing will be higher. Now, when we sliding the sliding contact to another side, you may see that the pointer of the ammeter is reduced, showing that the current flowing through the circuit is reduced already, because the current flowing from here to here and moving at the longer distance of coil wire to another side. Therefore, the longer the distance moving, the higher the resistance, and the lower the current will be flowing through the circuit here. Next, I would like to show you the simulation of connection of the rheostat with the second method, where the connecting is between terminal C and terminal A. Here, you can see that the cold-die clip is already connecting to the terminal C, where the position is at the top left side. And now, we are connecting the another connection to the terminal A. And now, we are showing that the deflection of the current at this position showing the highest reading. This is because the current is going from here to here and here with the shorter distance, and the resistance will be lower at this position, so that the current is higher. And now, when the sliding contact is moving to another side, you can see that the ammeter reading is reduced due to the resistance is become higher, because the current from here will be flowing to here and moving with the longer distance at the point of wire and to this position and throw up, so that the longer distance of the point of wire producing the higher resistance and the current will be reduced. Last, I would like to show you the wrong method of the connection of the rheostat, which is at the terminal A and terminal B, and you should avoid the connecting of the rheostat with these two terminals. Here you can see that the rheostat is connecting at the terminal A and terminal B, which is at the lower part at the rheostat, and you can see the current is showing at the 0.1 ampere. When we are moving the sliding contact to another side, the reading of the ammeter is remain the same. This is because at these two positions, the length of the point of wire is remain the same, even removing the sliding contact with these two positions. And you can observe that the current is always the same, whatever we are trying to moving our sliding contact to left and right. This is because the resistance is remain the same with the same length of the point wire, so that you should avoid the connection of the rheostat at terminal A and terminal B. That's all for the simulation regarding the connection of rheostat. And now we continue connecting to the cordite clip with the another buttons of the rheostat, and the another ends of the cordite clip are connecting to the 1 ampere of the ammeter. Make sure you have reading the correct scale, and make sure connect to the metal parts of the terminal positive of the ammeter. Next, connect to the negative terminals of the battery holder, which is in the black color nuts. Make sure you connect to the metal parts of the battery holder. And now, another end, we have to connect to the negative terminal, which is in black color nuts. Make sure that is connect to the metal parts of the ammeter. And we have complete our circuit in series. So you can close the switch and the deflection showing that the current is flowing and our circuit is functioning in the series circuit. Now we can continue to connect, okay, to our parallel circuit, which is connected with the voltmeter. So now we can start our connection with the positive terminal of the voltmeter, which is labeled with 5 volts. 5 volts. Okay, so connect to the metal parts of the 5 volts button, positive terminal with red color nuts, and you have to read the scale of the 5 volt scale, which is in the below of the ammeter. And another end connect to the metal parts of the crocodile clip at the positive terminal of the battery holder. And lastly, okay, connect the wire to the negative terminal of the voltmeter, and the another end connect to the negative terminal of the battery holder, and make sure both of the crocodile clip is connecting to the metal parts of the crocodile clip metal parts to each other. This is a close-up view to show you that how two crocodile clip connecting at the terminal positive and terminal negative at the battery holder. So firstly, make sure that the metal parts of the crocodile clip connecting to the another crocodile clip at the battery holder. This is similar also at the terminal negative. The two crocodile clip of the metal parts contact to each other. Now you can close the switch, and you can see the deflection of the both voltmeter and ammeter, and we can start to collecting our 5 readings of the manipulated variable, which is we are measuring the current with ammeter. So now we have to checking our maximum value and minimum value of the ammeter. The minimum value showing that there is about a value of 0.1 ampere. So there is 0.1, and now we go to measuring the maximum value that is more than 1 ampere, so we can arrange about to 0.9 ampere. So we are sure that the ammeter able to measure the reading about 0.1 to 0.9. So we have to collecting the 5 data. So following the question, so the first 0.2, 0.3, 0.4, 0.5 and 0.6. So we have to have 5 readings of the manipulated variable. So let us measure the first reading, that is 0.2 and 1.15 volts for the voltmeter. This is a close-up view for taking a reading on a voltmeter. You can see an image is formed on the metal strips. Therefore, the Planck's error is occur. Your eye should be at this position so that there is no any image formed on the metal strips. At this position again, you can see the image is formed on the metal strips, so that you must ensure that your eyes is exactly in the front of the mirror when taking a reading on a voltmeter, so that no image is formed on the mirror strips. The second value will be 0.3 and 1.10 volts. Then the next reading is 0.4 and 1.05 volts. And the fifth reading 0.5 and 0.95. The last will be 0.6 and 0.9 volts. So that's all for our readings. Okay, so that is the conducting the experiment regarding the experiment 3.5. Okay, so I hope that the experiment I conducting now able to help you to understand the procedure in our real world. So that's all. Okay, so students, after the experiment, you have already get your 5 manipulated variable here, which is the current, and you have also recording your voltage for each manipulated variable here. So the question number 1, okay, normally will be tabulation. So here we read the question together. So what is the instruction given for the question? The experiment above, tabulate your data for value V, okay, value V, I, 1 over I and R. Okay, so you have to tabulate these 4 quantity physics in the space below. So basically, so you have to make a table like this. So there is 3 important tips to tabulation, and make sure you fulfill these 3 tips here. The first, you must give all parameter or symbol. Here will be I, V, 1 over I and R. Make sure you write all the symbol at each column. Second, you have to give the correct unit. For example, current will be ampere, volts will be voltage will be volt, 1 over I will be per ampere, then the resistance will be ohm. So and here the I showing the 5 manipulated reading where we get by measuring by using the ammeter, while the reading for voltage here is measured by using the voltmeter. So as mentioned that the graph we need to plot the graph, we need 1 over I and also R. Okay, so for 1 over I, before we go to 1 over I, this is the third tips you have to follow. So make sure all the column, all the reading here, we have the consistent decimal point. So that means we need, like here, the first one 0.2 with 1 decimal point. So all the value here must following with 1 decimal point. And then the second one for the voltage also the same. The first reading we get is 1.15, which is with 2 decimal place, 2 decimal place. So that means all the data here must be follow the same decimal place number. So for example, 1.153, 2 decimal point. The second 1.10. If let's say you write as 1.1, that means there will be only 1 decimal point. And the third reading 1.00. If you write as 1, so that means there is no any decimal point. So the value given like this will be have the deduction mark in this question. So that means you need to have the consistent in your decimal point. Okay. Okay. So now this is a calculation for the first reading of 1 over I. So 1 over 0.2, which is the first reading for our current, then you will get 5. Normally, we will put the answer in 2 decimal place. So the next reading will be 3.33, where we get from 1 divided by 0.3. So the next will be also the same calculation method. So again, make sure that you have given the consistent in decimal point. So for R, there will be Ohm's law. So we will divide V with I. So at here, the first reading for V will be 1.15. Then the first reading for the current is 0.2. So after calculate, we get our first reading is 5.75. So the second reading also calculate by using the same formula. So again, make sure all the value have the same decimal place. If you fulfill these 3 tips here and the calculation all is correctly, so you will get full 6 marks. Now we are going to our second question, 1B. So the question only will be ask you to draw the graph. So let us read the question together. On the graph paper given, so draw the graph R against 1 over I. The R and the value R and value 1 over I we have already calculated at the question A. So the data is here, is showing here. Okay, so to get the full mark in this question, plotting the graph, there are 6 tips you have to remember. So the first, so you have to write the correct symbol at the x-axis and also the y-axis here. And then the next, you have to give the correct unit for x-axis and also the y-axis here. So the third tips here, okay, so you have to select the correct scale. Okay, so the first, we need to identify what is the maximum value for our x-axis here. So our x-axis is 1 over I, so it's 5. And then the maximum value for the y-axis R, which is 5.75. So that means we must know the maximum value. Okay, so second, we need to choose the correct scale. Okay, so what is the correct scale here? Okay, so all the value must be started at 0 here. Okay, so the scale here, that means the one box here representing 1 unit. If you measure by ruler, this is about 2 cm. So the 1 unit representing how many unit here? The unit here you choose must be multiplication of 1, 2, 5, and 10. You are not allowed to choose the scale of 1 unit representing with 3, 6, 9, or 4, 8, 12. So you are not allowed to choose besides the multiplication of 1, 2, 5, and 10. Okay, so at here, our smallest division here, okay, is about 0.1 because we choose our 1 unit equal to 1. Okay, so that means the smallest division for our x-axis will be 0.1. For the y-axis, we also choose the 1 unit representing 1. So that means the small division for the y-axis will be also 0.1. So this is the tips. And the tips number 4, you must ensure that your graph size must be at least 4 units by 5 units. So what means 4 units here? So that means we have to draw at least 4 boxes here for x-axis, and the y-axis must be at least we have 5 columns here. So that means equal to 10 cm. So this is the minimum size you must draw on the graph. Okay, so the tip number 5. So you have to plot all the points correctly. So the first point is 5.00. Y-axis will be 5.75. So as mentioned, our smallest division at x is equal to 0.5. Actually 0.1. So we have to round off our value. But 5 is not any problem. Okay, we can straight away get 5. Okay, however, as mentioned that the y-axis also have the same smallest division, which is equal to 0.1. So for the value y, the first reading is 5.75. So we have to round off the value to become 5.8, as the smallest division only we have 1 decimal point. So this is the first reading. Okay, so the first reading here will be about this location, where it's 5 and 5.8. Okay, for the second value, also the same. We have to round off 3.33 become 3.3 for x-axis, and then the y-axis 3.67, we round off become 3.7, and then we get this point. The method will be same for another 3. Okay, so you will probably get this 5 point here. So what is the next step we have to do? So we have to draw the best line. So what it means by best line here? So the best line here, that means that there are few points at the upper parts of the line, and then the lower parts of the line also consists of other points. This is balance for the upper parts and the lower parts for the point. So this is considered as a best line. So actually the data below the lowest, the 5th point, actually we do by extrapolation. So normally our experiment, all the graph will be passed to the origin, but the experiment for 3.5, after the modification, we plot the graph R against 1/i. The graph is no more passing through the origin. So this is a thing you have to remember if we have already do the modification. So the graph pattern will be changed. Hopefully this is a step you have to remember when you're plotting the graph. Okay, so we go to the next question regarding the data analysis question. So this is a question here. By using the formula, so the question given you the formula R equal to E over I minus R. On the graph, determine the internal resistance of the dry cell. Okay, so how we can get our reading of the internal resistance by using the graph? The tips actually is in the formula, so we have to rearrange. Okay, so the graph will be probably like this. Okay, so where is our our R? According to this diagram, so which is the SPM of 3.5. Okay, so the R representing as external resistance, E is E.M.F, I is the electric current, and R is the internal resistance where we need to find out. This is the detail for the symbol for the equation. So we have to rearrange the formula to become the format of Y equal to MS plus C. So as we draw the graph, R against 1/i. So our Y will be R and X will be 1/i. From here you can see that actually the E here is E.M.F, is actually representing as the gradients, while our internal resistance actually is representing as the y-intercept. So this is y-intercept. So from here we know that C is equal to negative R. So R will be negative C. Okay, so where is C? C will be here. If we zoom in, so the value here will be about 0.4. The answer here, C is equal to negative 0.4. So the R will be 0.4. So we will get 1 mark, okay, for this answer. So now we go to the next question. So 1C2, this is also one of the data analysis question. So let's read the question together first. So on the graph, determine the electromotive force E.M.F of the dry cell. The graph will be here also. Okay, so where we can get our E.M.F. So again, we're using the same formula. So just now actually I already mentioned what's the symbol representing S. So from here again, we arrange the formula in the format of Y equal to MS plus C. Okay, from here again, Y representing as R, S representing as 1/i. So here the gradients of the graph will be E.M.F of the dry cell. So we need to calculate the gradients. Okay, here 3 marks. So the first mark, okay, as I mentioned, the gradients will be E.M.F. So the first mark you have to draw right angle on your graph. So you must draw a bigger triangle, right angle. So if I say you put your triangle here, so this is will be deduct 1 mark, okay, because the right angle is not big enough. Okay, so the accuracy for your answer will be reduced. So that they must have a big enough for the right angle triangle. So this will be the first mark. So and then we have to get the point at the vertex of the right angle triangle in the formula of the gradients y1 minus y2 s1 minus s2. So the formula you have already learned in your PT3 mathematics. So you press calculator, then you will get the reading 1.19 with correct unit together. Okay, so you will get probably the second mark for the substitution and the third mark for the answer with correct unit. So this is E.M.F I get in my experiment. Okay, so normally student will be asked, okay, why this is not 1.5? Because normally one battery will be about 1.5. So this is because maybe the power of the battery itself is already low. So this is my reading. Okay, you can have your own reading on your experiment. Okay, so the next question will be regarding the precaution. So let's read the question together. Step 1 precaution that should be taken to improve the accuracy of the result of this experiment. So normally precaution we have already learned how to write in your compulsory report. So here the answer here is switch off the circuit immediately after the reading is taken to avoid overheating of wire. As the wire temperature increase, the resistance of wire will be changed. So the result you get will be affected. Another answer I advise here will be ensure your eyes is exactly in front of or using perpendicular to the mirror of the middle strip on the voltmeter and the ammeter to avoid the parallel error. So this is question D. Okay, and then we go to the last question. Normally end up with the hot question. So what will happen to the current when one dry cell is added and in parallel in the experiment? Okay, so that means in this experiment we conducting by using one dry cell. So the question asking you, if I say now I am adding one more, here actually is a note take out from the textbook. So now the question asking you to add on one more parallel. What is the effect? So you can see the effective internal resistance will be reduced. If let's say we add on one more, so that means the resistance will become half already. So this is the changes for the internal resistance where the value will be reduced. Okay, if you adding one more dry cell in parallel, and the E.M.F is not affected, it still remain constant. Okay, so what is the effect for the current? So again, we're using the formula where we have already learned in the section 3.5 here. E is equal to capital R, where is the resistance, plus small r, which is the internal resistance. Okay, so at here you can see the constant is at the E.M.F and also the resistance, because we have not adding any extra buck or resistance in the circuit. Okay, so it will be remain constant. And here when we have add on one more battery, so that means that here the notes here showing that the reading of the R will be reduced. So it will causing the current to increase by using the formula. So we know that the answer here will be increases. Okay, so I hope that my discussion today will help you to get more idea to answer your paper 3. So that's all. Bye.